Okay, this is lecture 4 of the subject, integral calculus. Okay, so in this video, I will be discussing about the initial condition or the constant of integration C. How do we get the value of C? Now, the constant of integration C may be of interest in some applications. So in such cases, we may specify a point that is a solution of the antiderivative, thereby allowing us to solve for C. This point is called an initial condition. So given a problem, if there is an initial condition, we can use it to solve for C. Okay. So simple example is find a function f such that the derivative is 2x minus 5 and f of 1 is equal to 4, which means that the value of the function when x is equal to 1 is equal to 4. So this is our initial condition and we will use this one to solve for C. Okay. So first, let us find that function in which the derivative is 2x minus 5. So the antiderivative of f of x na 2x minus 5 is, we will integrate this one. Integral of 2x minus 5 dx, it's x squared minus 5x plus c. So this is an antiderivative, or this is the antiderivative of this derivative 2x minus 5. Okay. So how are we going to solve for c, or the constant of integration? So since f of 1 is equal to 4, we let x equal to 1. 1 manali. We let x equal to 1 and the value of the function be equal to 4 at x equal to 1, and then we solve for c. So we will substitute f of x be replaced by 4 and then x replaced by 1. 1 and 1 and 4, 1 squared minus 5 times 1 plus c. C equal to 8. 1 minus 5, negative 4. Transpose, it becomes positive. So 4 plus 4 equals 8. Therefore, the function that satisfies the initial condition is this one. So if we will substitute x equal to 1, 1 minus 5 times 1 plus 8, the answer is 4. So f of 1 is equal to 4. And that satisfies the initial condition na f of 1 is equal to 4. So for every problem, there must be an initial condition that we can use in order to solve for the constant of integration. Okay, so next we are going to solve a worded problem. Okay. And still, it involves constant of integration, finding the constant of integration. Uh, this is the problem. A baseball is thrown vertically upward with an initial velocity of 75 feet per second from an initial height of 30 feet. The velocity of the ball is given by the function v as a function of t is equal to negative 32t plus 75, where t is the number of seconds since the ball was released and v is in feet per second. So question A, find the function h that gives the height in feet of the baseball after t seconds, using the fact that at t equal to 0, the ball is 30 feet above the ground. So it means that this is our initial condition that at t equal to 0, the ball is 30 feet above the ground. Letter B, what are the height and the velocity of the baseball after 2 seconds of flight? And then C, after how many seconds does the ball reach its highest point? With the hint that the ball stops for a moment before starting its downward fall. So, momentarily, ang velocity sa ball is equal to 0 at the highest point before it starts downward. Letter D, how high does the ball get at its highest point? Or meaning, maximum height reached by the ball. And then letter E, after how many seconds will the ball hit the ground? And last is, what is the ball's velocity at the moment it hits the ground? Okay, so let's try to answer these questions. So first is, this is the expression of V, negative 32t plus 5, plus 75 rather, given the problem. Diba? And we all know sa physics that the velocity is the rate of change of its distance with respect to time. Diba? Or since pag horizontal motion, pag vertical motion, velocity is rate of change of its height with respect to time. Or simply, V is equal to dH over dt. So we will replace V by dH over dt. Or rate of change of height with respect to time. That's V. And this is discussed sa physics. And cross multiply dt, we have this. And we integrate. And integral of dH is h lang as a function of time. Derivative of negative 32t, t squared over 2, 75t plus c. And then we have this one. And so let us solve for c. This is our initial condition, di ba? Yeah. At t equal to 0, the ball is 30 feet above the ground. So when t is equal to 0, h is equal to 30. Oh, so from this one, 30, and then t equal to 0, 16, 0, c is equal to 30. This is our constant of integration. And so our expression of h is this one. H is a function of time is equal to negative 16t squared plus 75t plus the constant of integration 30. Okay. So letter A, find the function h that gives the height in feet of the baseball after t seconds, using the fact that at t equal to 0, the ball is 30 feet above the ground. So our answer is this one. Oh, from this one. From this one. Letter B, what are the height and the velocity of the ball after 2 seconds of flight? So, when t is equal to 2, find h and v. So, from this expression, we will just substitute t equal to 2 sa expression of h, and we can solve for h. And the answer is 116 feet. And for v, this is our expression of v. There. Negative 32t plus 75.
Mm.
Substitute t, sorry, t equal to 2 and our velocity is 11 feet per second. Letter C. After how many seconds does the ball reach its highest point? Our hint is the ball stops for a moment before starting its downward fall. Okay, example, initial height sa ball is 30 feet above the ground. So it's being released or thrown vertically upward until it will reach the highest point, such as this. Okay, so what will be the time or after how many seconds will the ball reach its highest point? And with the hint that at the highest point, the ball stops. Okay, so at the highest point, V is equal to 0. And we can make use of this expression sa V. Uh, so V as a function of t is equal to negative 32t plus 75. So when the velocity is 0, we can solve for t. So it's 75 over 32 or simply 2.34375 seconds. Letter D. How high does the ball get at its highest point? Okay, so how maximum height reach. So if this ball is thrown upward, okay, what will be the value of h? So from this is the expression of h, and mm, we will use the value of t sa previous na question na when the ball reach the highest point, the time consumed is 2.34375 seconds. Sa question C. So let us substitute this value sa expression sa H. And the value is 117.89 feet. This value substitute here and also this one. Letter A. How many seconds will the ball hit the ground? But actually, this time includes the time going up and going down. So time from the release until highest point and then downward until it will reach the ground. What's the total time? Okay, remember that when the ball hits the ground, ang h niya is equal to 0. Okay, this expression is height of the ball, man. Height of the ball above ground level. So therefore, we equate h to 0 and solve for t. And to solve for t, either you will use factoring, pag pwede ma-factor out. If not, then you will use quadratic formula. And assuming that you already know how to use quadratic formula, then the value of t by using quadratic formula is 5.058 seconds. And if last, what is the ball's velocity at the moment it hits the ground? So when it hits the ground, h is 0, and t equal to 5.058. Now, uh, we will substitute this value to the expression of v. The ball will hit the ground after 5.058 seconds. And since this is the expression of v, substitute t 5.058 seconds. The answer is negative 86.86 feet per second. Negative sign means downward. Okay, downward direction. Okay. That's the meaning of this negative sign. Another problem. Okay. So as early as now, let's train. I'm going to train yourself or train yourselves to analyze worded problems. Suppose that a car can accelerate from 30 miles per hour to 50 miles per hour in 4 seconds. Assuming a constant acceleration, find the acceleration in miles per second squared of the car and find the distance traveled by the car during the 4 seconds. So, get the expression of acceleration. Again, from physics, acceleration is the rate of change of velocity with respect to time. So, A is dv over dt. Eh? Acceleration, rate of change of velocity with respect to time. So, cross multiply, we have this one. Our acceleration is constant, A. So, integrate uh, constant dt using the constant rule, V is equal to Et plus C. So, we have two unknowns, A and C. But we have two initial conditions. Uh, it should be that if we have a number of unknowns, we must have a number of initial conditions also so that we can solve for the unknowns. And since we have two unknowns, we have two conditions. The initial condition is when t is equal to 0, the velocity is 30 miles per hour. This will be our reference man. So 30 miles per hour is when t is equal to 0. And after 4 seconds, the velocity becomes 50 miles per hour. Okay, so these are our initial conditions. Velocity is 30 miles per hour when t is equal to 0. And the second one is velocity is 50 miles per hour when t is equal to 4 seconds. But before we will solve for this, the required quantities such as acceleration and the distance, let us first fit the given units now. What is asked is for acceleration, it must be in miles per second squared. And since the given unit is miles per hour, we're going to convert hours to seconds. As is lang ang miles. So, for 30 miles per hour, this is the conversion. For 30 miles per hour, 1 hour is 60 minutes, 1 minute 60 seconds. So, makancel ang hour, cancel sa ng minutes. So, what remains is miles per second. So, divide 30 by 60 and 60, the result is 1 over 120 miles per second. Do the same for 50. Cancel, cancel. 50 divided by 60 and 60, the result is 1 over 72 miles per second. Okay. So, okay. Initial condition, first initial condition. At t equal to 0, v is equal to 1 over 120. Okay? At when t is equal to 0, v is 30 or simply 1 over 120. And this is our expression of v. So replace v by 1 over 120 and replace t by 0. And therefore, c is equal to 1 over 120. And to solve for a, you use the second condition. When t is equal to 4, v is equal to 50 or 1 over 72. Okay. So use the same expression for v 1 over 72, a t equal to 4 with c equal to 1 over 120. So you simplify, you transpose 1 over 120 to the left side, 1 over 72 minus 1 over 120, the result, divided by 4, and you have a equal to 1 over 720 miles per second squared. Because the unit of V is miles per second divided by second, it becomes miles per second squared. The second unknown quantity is the distance traveled. Um, Find the acceleration, already solved. And the other one is find the distance traveled during the 4 seconds. So distance traveled after 4 seconds, uh, we have to find the expression of distance. And we all know sa physics na to solve for distance, we need v. No? Since velocity is the rate of change of distance with respect to time. So this one, v is equal to ds over dt. And velocity is rate of change of distance with respect to time. So cross multiply, you have this ds equal to v dt, and then you integrate. Now v is not a constant. It is it is it's a function equal to this one, et plus c. So we are going to substitute a and c sa expression of v. We have this. Our a is 1 over 720 and our c is 1 over 120. This one. So we will substitute this expression of v sa integral. So s is integral of this one dt. And use power rule. T squared over 2. 720 times 2 is 1440. And then 120 times t plus c. Again, let us solve for this one. Now, this constant of integration c is different from this one. C 1 over 120. You can use others. You can use subscript like C1, C2 to differentiate this one sa previous na C if you want. Our initial condition for distance is this, that at t equal to 0, distance is equal to 0. Although, although it's not given sa problem, but it's very obvious na when the car has not yet started, of course, the distance is equal to 0. Diba? So at t equal to 0, implied siya na distance is also equal to 0. So substitute, t equal to 0, 0, s also equal to 0, and therefore, our constant is equal to 0. So to solve for distance, we'll substitute t equal to 4. So at t equal to 4 seconds, so s, you replace t by 4, and the answer is 2 over 45 miles. Since since our unit for V is miles per second, so the distance will have the unit of miles. So that is how you're going to solve for the constant of integration. So always remember that for every problem, there must be an initial condition that we can use to solve for the constant of integration. So I hope that you have learned something from this. Thank you for watching.